Hi all, hope you all are doing good. So today we are going to discuss about a beautiful planet which is a home to animals, trees, plants, human beings, birds and all other living beings which exist in this world. Yes, we are going to learn about Earth. Earth is the only planet in the entire solar system where life exists. And Earth is called a blue planet. Why it is called a blue planet? Because 71 percentage of Earth's surface is covered with water and only 29 percentage is land, which constitutes the continents. So that's why the Earth is called a blue planet because it appears blue in color. And if you take the Earth's atmosphere, that is the mixture of gases which are surrounding our Earth, it consists of 78 percentage of nitrogen and 21 percentage of oxygen and traces of other gases like carbon dioxide, water vapor, etc. So all these conditions make the Earth habitable, where all the living beings can live. And now I have a question for you. If I'm standing on Earth, and we all know Earth is floating in space, how come we are not falling down from Earth into space? How is that we are still on Earth? Because I can be standing here, I can be standing here. We all know Earth is not flat in nature, it is spherical in shape. So, in that scenario, how come I am not falling down from earth even though I am standing at the edge of this earth? Just think over it. Okay. So the answer is gravitational force. I know few people would have answered that, which is good. So gravitational force is the force because of which we are still on earth without falling down into space. Gravitational force will be attracting us towards the center of the earth. So whether I stand here, whether I stand here or I stand here, I will not be falling down because the earth is pulling me towards itself through the gravitational force. In case the earth loses its gravitational force, what will happen? Now if I am standing here, I will fall into the space, okay, and I will never come back. And if I'm standing here and I jump, I will go into space. I will never be pulled back because of the gravitational force. Even if I'm jumping, I'm being pulled back to the ground. In case there was no gravitational force, if I jump, that's all, I'll be going and leaving the earth and going into space. So that is the reason we are not falling from the earth down into the space. And you know, Earth is the third planet in our solar system. So we all know about the solar system. This is we have the eight planets which are revolving around the sun. So we have Mercury, which is closest to the sun, then Venus, and our Earth, if you see, it occupies the third position. We have Mars, we have Saturn, we have Jupiter, we have Uranus, we have Neptune. So all these planets are rotating around the sun, and in that, our Earth takes the third position. So it is in this third position, the Earth is rotating around the sun. Now, the Earth rotates in two ways. One is the Earth rotates around itself. So the Earth is self-rotating. Okay, this sphere spins around itself, and also earth is rotating around the sun. So two rotations are happening in the sun. One is it's rotating around itself, and the other one is it is rotating around the sun. So now, because the earth is rotating around itself, so it is rotating like this, we are having day and night. Okay, and The Earth takes 24 hours to complete one rotation around its axis. So, if you see here, if I'm standing on this side of the Earth, this is facing the Sun. Now we know Earth is rotating around itself. So now Earth will rotate, and the person will be moving towards this side. So what happens now? This person will not be able to see the sun, so there will be night in this area. So when this rotates and goes that side, he will be seeing night. So we have half a day night, half a day. Um, we have 12 hours of night and 12 hours of daytime. So that's why we have total 24 hours when we are on this earth. Now the earth rotates around the sun, we know. So how long does it take to rotate around the sun? It takes nearly 365.25 days to rotate around the sun. This is nothing but 1 year. So the earth is taking totally 1 year to rotate around the sun. Okay, and the earth is located at a distance of 150 million kilometers from the sun. So if it calculate the distance from sun to earth, that is nearly 150 million kilometers distance. So that much far away our earth is from the sun. That's why we are not getting no, burnt. It is an ideal place where life can exist. It's not very near to sun where it will be no turning the earth into molten ball, or it is not far away like Neptune and Uranus where it will freeze. So it is at the exact nice habitual position where the living beings can exist without any issues. Okay, so now you would have seen outside of the earth. Now let us see what is present inside the earth. So what rocks are present, or what is present inside the earth. Okay, so scientists did lot of research, and no, they found there are so many layers inside the earth, and this earth they divided into different layers, just no to be based on their function and how they behave, they were divided into different layers. So now we will be seeing into that layers. The outermost layer, if you can see the gray one, which is no very thin layer, which is very solid in nature, rocky, which is called the crust. So this is the layer on which we all are residing. Your plants, your ocean, our human beings, animals, everybody, we all are living on this crust which is surrounding the earth. So this small crust is divided into two types of crust. One is continental crust and another one is oceanic crust. So continental crust is the crust where all the continents are located. That is that 29 percentage of land which we saw. And oceanic crust is the crust or the layer which is under the oceans, so on which the oceans are located. So this crust is the outermost layer. It is very no, brittle and solid in nature, where we are able to stand and we are able to establish our civilizations on this crust. Next is the below layer. It is called the upper mantle, and we have a mantle. We have two layers, upper mantle and lower mantle. And one more thing is about the crust, which I did not mention. The temperature here varies between 15 degrees Celsius to 1000 degrees Celsius, and the depth, how deep it is, 5 to 70 kilometers distance. So 5 to 70 kilometers distance, the crust extends to that depth. Next is the mantle, which consists of upper mantle and lower mantle. See the orange one and the this circle and this circle, these both circles, they constitutes the upper mantle and the lower mantle. So if you see the upper mantle, the topmost part of the upper mantle. So in this orange circle, the topmost part, okay, topmost part is solid in nature, okay, and the part which is below it is semi-solid and partially molten zone. That is, it is in a flowy tar-like liquid, gooey liquid which is flowing. That rock is not completely solid. It's like gooey, when if you keep your leg there, your leg will get stuck in the tar when the roads are laid. This tar is very sticky and gooey, right? That's how the part below the topmost part of upper mantle is there. So upper mantle is topmost part is solid, is a mixture of solid and semi solid. So upper part is solid, the part which is below it is semi solid. Now based on this state of matter, if you see, these have been divided into different physical layers depending on how they behave. So this crust as well as the topmost part of upper mantle, okay, which is solid. This is solid, crust also is solid. So crust plus top edge of the upper mantle, this together are called lithosphere. Okay, just a naming convention they have used because to differentiate in which nature they are. Now these both are in solid nature, so they have named the crust as well as the top edge of the upper mantle as lithosphere. Okay, this is what lithosphere is what breaks into tectonic plates. We will see that tectonic plates later, but just remember this tectonic plates is this uh, crust or the lithosphere dividing into several pieces, like a inside a puzzle we have many pieces, and those are all joined together, right? So like puzzle pieces, these are all broken into small small parts, so that are tectonic plates. We'll see that later. Next, we have to see the upper mantle is extending from 70 kilometers to 650 kilometers, and the temperature varies from 1000 degree Celsius to 1000 degree Celsius. Okay. Now, the remaining part of this upper mantle, we have seen the crust and the topmost part of upper mantle is called lithosphere. Now, the remaining part of this upper mantle, which is semi-solid in nature, we discussed, right? That is called asthenosphere, which is gooey and plasticky. Remaining upper mantle below lithosphere, the tectonic plates slide on this hot, slow-moving tar. So, the tectonic plates which we discussed, okay, are partitioned or broken partitions places. These are moving on this hot, slow-moving tar. So, these are moving on this. So literally we are all moving, but because that movement is very slow, we don't feel that. When that movement is huge, that's when we feel that earthquakes, tremors, all that. But because the movements are slow, we are not feeling that uh, movement that these plates are moving on that tarry liquid, hot tarry fluid. So that is called asthenosphere. So now next comes the below the upper mantle is the lower mantle. Now this one is very solid, denser, and very high pressurized. So the pressure increases as you go deeper into the earth. So because of that pressure, this particular lower mantle becomes solid. Even though see upper mantle's lower part was semi-solid, but the part which is below it becomes very solid, and it's very denser and high pressure. This extends from 660 kilometers to 2890 kilometers, and temperature varies between 1600 degrees Celsius to 4000 degrees Celsius. Now, this part, this denser solid part is called mesosphere, which is solid and liquid, rigid. Very solid and rigid, so this is called mesosphere. Okay. Next is your outer core. So the yellow circle, inside most circle. This circle surrounding that pink circle, the yellow circle, this one is called the outer core. This one is again, now see, now this becomes in liquid form, this is liquid metal, where it consists of molten iron and nickel. These both are in melted form present in the outer core, and this is at the depth of 2890 kilometers to 5150 kilometers. Temperatures varies between 4000 degrees Celsius to 5700 degrees Celsius. See how high temperature is increasing as we go deeper into the earth, and the pressure also is increasing as we go deeper into the earth. Okay, and that is called outer core, is also called outer core itself here, that is liquid metal. Now we have the inner core. Now inner core, innermost core, the pink one, this becomes solid because of the immense pressure. So now as the pressure is increasing, imagine at the very middle of the earth, here the pressure is the maximum. So because of that, it turns into solid and forms iron and nickel alloy. So it forms the iron and nickel alloy here, hard metal. It is at a depth of 5550 kilometers to 6371 kilometers. This is the center of Earth, 6371 kilometers, and the temperature varies between 5700 degrees Celsius to 6000 degrees Celsius. See how high the temperature is. So that is called the inner core, and this is the solid metal. So solid metal form, this innermost core is made of. Now you have seen how different layers of earth are present. See, outside when we see it's just a land, mud, rock. We would have seen only this many things. But if you are going deeper inside, have you ever thought, no, there is no magnum flowing, how the tarry liquid is present, how the pressure is increasing and your temperature is increasing, but we are not feeling the temperature. So that's why we do not know, no, temperature is so much high in middle of the earth. If the same temperature is there on top of the earth, then we all will be burnt. So this is about how the inner structure of the earth is. So next we are going to see about the earth's natural satellite. So what is the earth's natural satellite? Any guesses? The Earth's natural satellite is, yes, Moon. Moon is the Earth's natural satellite. All other satellites which are no rotating in the space, which are used for our television communication, all this for communication, satellite communications for all other purposes, those are all artificial satellites which have been sent by human beings into space. But Earth has only one natural satellite, which is Moon. So, what is a satellite? So, satellite is nothing but any celestial body, any celestial bodies, any natural object which is present in space, which is rotating around another celestial body, that is our Earth. Our Earth is a planet because it is rotating around a star, which is Sun. Sun is a star. So, Earth becomes a planet because it is rotating around a star, and Moon is a satellite because it is rotating around the planet, which is no, not a star. So any object which is no rotating around the earth and stays in its earth's axis, gravitational pull, the earth's magnetic power, it continues to rotate around the earth, is called a satellite. So now here moon is our natural satellite. So why we are seeing about moon? If there was no moon, imagine no moon is there, no satellites for Earth. What will happen? Moon is doing many things which we don't know. We thought moon is just present there rotating around the Earth and it does not have any purpose. Moon is rotating around the Earth and it is doing lot of things. So we will see that. Now suppose if there was no moon, what will happen? At night, you would have seen on days when there is no moon, it's pitch dark. So there won't be any light if moon is not present. Then if moon is not there, your earth will start rotating faster. You know that? Because three times faster it will rotate. Because moon also has some no power with which it is acting like a brake to the earth. So earth is rotating around itself, so it will be rotating very fast. If moon is like a brake applied to the earth, so now moon is rotating at one small speed instead of high speeds. That's why we are having 24 hours. In case no moon was not there, then your day will be only 6 hours. It will just rotate three times faster and your days will become shorter. You will only have 6 hours in a day. Okay, so that much work moon is doing. No, if moon was not there, what will happen is you will not be having any seasons, because moon's power is also causing that oceanic tides are there, right? Tides which are being produced in oceans. It's because of these tides, no, everything inside the ocean gets mixed up, and no, it helps in mixing the nutrients and helps the wildlife which is present in the marine life, which is present in the oceans. So moon is helping us in that way. And your moon, if it's not there, you'll not be able to have any seasons. Like we are having all different types of seasons, like summer, winter, because no, because this is controlling the earth's movement, and so we are having the seasons, like slowly summer is coming now. We are having different, say autumn is coming, then we have the winter. So everything is happening slowly because moon is controlling the earth's speed. So moon plays a very important role in that. And one more thing which moon does is moon is tilting the earth at a certain angle. Okay, so earth is tilted at an angle of 23.4 degree celsius, 4 degrees. So 23.4 degrees, it's the angle at which the earth is tilted. That's because of the moon. Okay, if suppose moon was not there, then the earth will go out of control and it will be tilting between 0 and 60 degrees. So what will happen? The earth will start wobbling. It will be shaking. Here, this between 0 and 60 degrees, it will keep wobbling. It's because of the moon's power. It is keeping the earth at this angle stable. 23.4 degrees. The earth is tilted at this uh, angle and it remains stable. It's happening it's happening only because of the moon. So see how much important the simple moon which is rotating around the earth is important. So people who don't know about the moon, now you would have got and understand how important the moon is. Next, we will be studying about these special phenomena. One is the lunar eclipse and the solar eclipse. So first we will see about the lunar eclipse. So what is a lunar eclipse? What happens during a lunar eclipse? Okay. So what happens during a lunar eclipse is, suppose your sun is there. We know earth is rotating around the sun and moon is rotating around the earth, correct? So now what happens? A situation comes where the earth is between the moon and the sun. Okay. So now what happens? Earth comes between the sun and the moon. That's when lunar eclipse happens. So what happens is earth will be hiding the entire light of the sun and from reaching the moon. So the moon will not have any light falling on it because the earth is covering its path from which it gets the sunlight. So the moon stays in dark place, and there are angles from the earth from which some amount of light passes. Okay, now see, the dark place where no light is passing is called the umbra, and the place where some amount of light comes and it is slightly faded is called penumbra. So now the moon, when we look at the moon from this angle, for example, if I'm standing here and I am in the umbra region where the light falling on the moon is completely stopped. So now when I look at the moon from this part, what I will see is I will see a moon which is blood red in color. That's why it's called a blood moon during the lunar eclipse. So blood moon, in the sense, what happens is the light from the sun, whichever is there, the blue color gets um, scattered because it has low wavelength, and red has longer wavelength. So what happens, red gets refracted, means it gets bent and falls on the moon. So because earth is in between and it is blocking the light, so whatever light is being reflected from earth is what is going to fall on the moon. So if what happens from the earth, the blue light gets scattered because it has short wavelengths, it cannot move further away, but the red light having longer wavelength will pass over the earth, whatever this light is escaping and coming, and will fall on the moon, and that's why the moon appears dark orange or blood red, and that's why it's called the blood moon. And if we see from the region where somewhat sunlight falls on the moon, like this penumbra region, you will be seeing like normal moon with some faded light. But from this region where there is no light falling on the moon, the region where completely the sunlight is blocked, the people from there will be able to see the blood moon, red colored moon. So this is the lunar eclipse. So this is what we'll be able to see on the lunar eclipse day. Okay, and because this we are seeing only the moon, that one is not very harmful for the eyes as well, because we are not seeing the sunlight. Sunlight is harmful, but here we don't have no direct sunlight falling on our eyes, so we can see this with our naked eyes, this blood moon. Next comes the solar eclipse. Okay, now solar eclipse, what happens? Same thing we see. Now in this scenario, same thing, sun is there, earth is there, moon is there. Now what happens, moon comes in the path of the earth as well as the sun. It comes in between the earth and the sun. So moon is if moon comes here, earth is blocking, it becomes lunar eclipse. Now moon is rotating, and it comes in a place where it blocks the earth from the sun. Okay, so the sunlight is being blocked. So the region where the sunlight is being blocked here in this part of the earth, this one, see, this region where it is completely dark, that will be called the penumbra, sorry, umbra. So where there is no light passing, okay, this region becomes your umbra. And where there is slight light passing from the edges of the moon, that one will be called penumbra. Okay, the light color part where somewhat light escapes and reaches the corners, that is penumbra. Now what happens in this part where there is no light passing, if the person stands in this part, so this part is completely dark because the moon is hiding the sunlight completely. So if I stand here and see, I'll be able to see the full eclipse. So this part if I see, I'll see full eclipse. Full eclipse, eclipse means what will happen? I'll be seeing a moon, and this will be surrounded by complete no ring like structure. So I'll be able to see a ring, a golden ring like structure, a light surrounding the moon. Okay, because in the between, the moon is being blocking the sun, and around it the light is flowing. So from here I'll be able to see a golden ring structure. Now if I am in a partial eclipse zone in this penumbra region, I'll be seeing a partial moon, like it will be, partially colored moon. It's like not colored, I mean partially lighted moon, like somewhat it will be faded moon, but you'll still light will be falling on the moon, and some of the moon will be hidden, some of the moon will be visible. Somewhat like no half moon, quarter moon, which we see as the moons having different circles. That type of moon I'll be able to see from the penumbra region. That is, I'll be able to see a partial eclipse. So this is about the solar eclipse. Hope you have understood about the lunar and solar eclipse. Now, this solar eclipse we should not see with our naked eyes, because it is the sunlight which is falling and it will be very sharp and our eyes will be affected. That's why we had to wear protective gear to watch this solar eclipse. If you want to watch with our eyes, we have to wear protective gears. So, this is about the solar eclipse and the lunar eclipse. So now we had discussed about this tectonic plates. I had mentioned about this tectonic plates. Now we will see what are these tectonic plates. Okay. So tectonic plates. So this is the earth, and we have all our continents no spread. Land is there, water is there. So what happens in tectonic plates? What are these tectonic plates? As we saw, the lithosphere is the part which is divided into these tectonic plates. So what happens is, this entire earth is there, right? The crust, top layer, and the topmost layer of the upper mantle, what happens is it's no broken like eggshell. If the eggshell is broken right into different cracked pieces, that's how this entire area of that lithosphere or the crust top layer of the earth, if you see, the solid part of the earth is divided into various cracked separate pieces kind of thing. See, this one is separate, this piece is separate, but all are joined together like a puzzle. No, we have different pieces of puzzle, and if we join all the pieces together, then we get this entire area. Similarly, here the continental crust as well as the oceanic crust, mainly the lithosphere, that is divided into different pieces like this, which are joined. All these pieces joined together. It's not that they are having gap in between these plates. So these are joined in the edges or through the planes. So these are all called the tectonic plates. Okay. So these are what are called the tectonic plates. So I have marked with that red color lines. So these are all called the tectonic plates. So see, few countries or few continents, if you see, are inside the tectonic plates, so they are safe. But few countries are located in the joining part. So these tectonic plates are constantly moving, as we saw on the tarry liquid. So what happens is, sometimes these tectonic plates might collide, or they might shift if they are moving without any issues, or they are moving slowly without colliding, then there is no issue. But what happens is, because all are no beside each other, now if they are moving, it might no go and hit against this tectonic plate, or this might hit against this tectonic plate. What will happen? That's when earthquakes happen. And if it hits hard, we have these mountains getting formed. Himalayan mountains is formed, Mount Everest is there. How they are formed? Because these tectonic plates went and collided against the other tectonic plates, and they formed mountains. Sometimes they form mountains, sometimes we have cracks happening and volcanoes erupting, all this happens all because of this tectonic plates. So earthquakes which are happening, if you see, mostly it will happen in the places where there are tectonic plates joining. See, here there is a joint, here there is a joint. So whichever country is inside the tectonic plate, it's safe because it's not going and hitting in the middle. It will be just no um, joining or colliding at the edges. Okay, so these are called the tectonic plates, and the reason why these tectonic plates are studied is because this is what will help us in predicting the earthquakes, the volcanoes, all the internal activities of the earth. Because of this only we are having that natural disasters happening. So these tectonic plates are studied. So hope you have got some knowledge about our earth. So this is will be very important for you. So just to give you an idea about our earth, what is happening on our earth, and what are there on our earth, different things which you should know about the earth has been covered in this session. Hope you have enjoyed today's session. So if you like my video, please like, share, and subscribe. Thank you all.